Welcome back to Engineering Mechanics, EGM 3512. Now we are in the third part of the lecture, now that we passed the second exam and we are ready to wrap up the semester with some cool down. Now let's introduce the next topic, which is actually called truss structures, and some of you may have heard of trusses before, some of you have not. So let's first give a general overview. It's easiest to see in this top picture on the left that we have a truss system here, which is similar to the roof structure we had before, except now we have a bottom chord here, and then we also have these other members that pretty much create a truss structure. And you can see similar things in all the other pictures. Here on the right side, the Eiffel Tower, it's a very fancy truss structure. It's actually truss and truss and truss. And I will give you a more clear overview on the next slide. But here you see that we have, in a general sense, a big truss system here, but also within the individual members for structures like stages and party tents and stuff like that. You actually use truss systems because the benefit is that you need very little amount of material to span long distance. You see, this is a very long span, and that can only be achieved on lightweight with a truss system. So let me zoom in a little bit, and so let's actually draw on there that we have a truss here. So you see, like when I ask students usually, they always say trusses are triangular systems, and that is somewhat true, but it's not the whole truth. But you see that each individual component here also has trusses built inside. So, and that's a 3D truss. It's actually like 90-degree flopped. So if I pick another element, there's something here and here. And then there's also something here on the top. It's difficult for me to show that in this picture, but you get the idea that we have a big truss system, and then we also have the small truss system in between. So, and the same is true for all these other structures here. The Eiffel Tower, for example, has a very fine truss system within each of these members, but then these members make another truss system, and then the whole thing is truss after truss after truss. And here on the bridge on the bottom right, we also have a very clear truss system, and you can see that there's actually holes in these systems. So this is effectively also a truss, but it's more like a beam that has material removed to save weight. And the trick here for this truss system is probably clearest if we look at this bridge. Remember that we have a smiling beam. If the train drives over this bridge here, then this part wants to move down. And remember that we said if the beam is smiling, then we have tension on the bottom, compression on the top. And so the trick in these truss systems is really that the bottom chord and the top chord are very far removed from each other. Because if you do that, then you actually have an effective, very long lever arm between those two, right? So you have compression on the bottom and tension on the top, and everything in between just provides space. So that is kind of the idea behind a truss. And trusses come in many different forms. So there is also fancy names for them. That's not the part here of the lecture. And of course, we're not going to start with like very complicated cases first, but a system like this one here, the king post and the queen post, those are systems we will clearly be able to identify when we're done with this lecture. And let me just tell you that there are two methods to deal with these types of trusses, at least in engineering mechanics. That is the method of joints and the method of sections. And in today's lecture, we will really only focus on the method of joints, and I will explain in a second why it's even called method of joints. And the method of sections is something we're going to deal with in a following lecture. So 2 topics we will really discuss. Both of them are meant to analyze the forces within truss systems so we can design them later on. But today we only focus on the method of joints, and method of sections will follow later.